Hello, everyone. Welcome to my ISM presentation over forensic biology and serology. I hope you all are staying safe and doing well in quarantine. I hope this gives you some entertainment during these weird and troubling times. I'm going to be teaching you a lot of things in the next 30 minutes or so, including what I did in ISM this year and the last, what my mentor and I did throughout the year, which I'm very excited to share with you all. And I'm going to help you solve a murder, and one of you, a viewer, is the murderer. You don't know it yet, but you're the murderer. So let's get right on into it. This is something my mentor used to tell me, and it's the first thing he said was important when it came to forensic biology and serology. At our first meeting, he said, when two objects come into contact with one another, there's always an exchange of material. This is a very famous quote, and almost every forensic biologist, or even forensic scientist for that matter, knows this quote. It's just that famous. And we are going to be dealing with this idea that whenever you touch something, whenever you come into contact with something, your genetic material is always put somewhere. So if I put it on this wall, my genetic material is there. I'm rubbing it on my computer, it's there as well. So we're going to be dealing with that idea a lot in this presentation. So a lot of you are watching, you probably know what ISM is because you're watching this, but for those of you who don't know what ISM is, it's actually an acronym that stands for Independent Study Mentorship. Now let's break that down a little bit. Independent, you're on your own. In this class, you get a piece of paper every 6 weeks, which is a calendar, and it has dates and due dates and a variety of things. It's your job to get that done. It's your job to schedule things. It's your job to make sure that your work is being turned in on time. It's very much like a college course in that sense, and that's where we get independent from. Study. ISM is a apprenticeship, is the way I like to describe it. It is a class in which you are able to go find somebody who is in a field that you may be interested in doing when you grow up or majoring in college, and you are their apprentice. So you find something that is interesting to you, which could be a variety of things, ranging from anesthesiology to magic to guitar playing to potato picking. I don't know. As long as you're able to find a mentor and it's an actual job, you can take it in this class. Lastly, it's the most important letter of the three: mentorship. You need a mentor. I can't be going and, being a pharmacist and selling drugs and giving people prescriptions without an adult there. If you get what I'm saying, I'm not a professional, is what I'm trying to say. You need to find someone who's a professional in the field that you're interested in. And I was lucky able to find someone who was an absolute amazing mentor, a very nice man. I'll get to that in a second. But another part of ISM is Toastmasters. Now, this is not how to make the best toast, even though I do know how. If you're curious, text me and I'll tell you how to make the best toast. But it's not how to properly put it into a toaster. That's not Toastmasters. Toastmasters is a course in which you are trained to give toast. So what I mean by that is not a piece of bread on plate, but when you're in front of your friends and family at a wedding as the best man, and you have that whatever champagne glass, and you're giving a toast. In other words, it's public speaking. And so, as you can probably tell right now, I'm speaking pretty fluently, and I would be speaking the same way I am right now if I was in front of 20, 50, 500 people because of Toastmasters. They have almost conditioned us to, I guess, not freak out, because a lot of the time when people join ISM, they're not the best at public speaking. They use a lot of filler words, they pause, and they ramble on and on and on until they get faster and faster, stuff like that. So it teaches you to pace yourself, it teaches you just to calm down, take a breath, and everything will be okay. And that's what Toastmasters is. We've had so much fun with it. It's a part of it is improv, which I had a lot of fun doing, and I may do it in college. We'll have to see. But I talked about my mentor earlier, and my mentor is a man by the name of Mr. Garen Foster. I've known Mr. Foster for 4 years, technically. I met his son in world geography, and we became friends, and I met him through that. And he's always been a very nice man, a very smart man. His family actually invited me to go to East Texas with them. So I went on a 4-day trip, I believe, with them the summer of sophomore year through East Texas. So I got to know them pretty well. And I wanted to do something in sciences. And I did a soft science last year, which means that it's psychology. It's based off of concepts rather than evidence. And that could be argued that for psychology, you need evidence to do all these things, but it's something you hold in your hand versus something you know is happening. That's the difference between hard and soft science. So I studied forensic psychology last year, which is a soft science, and I was curious on the hard sciences, chemistry, physics, stuff like that. And so I got in contact with Mr. Karen Foster. I knew he was a forensic biologist. I always thought that was super cool. And I said, are you available to meet once a month and talk about things? And he said, of course. I work at the Bear County Crime Laboratory, and I could show you around and stuff like that. We could do experiments. And with that being said, there are three things that Mr. Garen Foster or any mentor in ISM really has to do. Number one, it's the most important, debatably, but I think so, is mentor meetings. Mentor meetings are once a week, but you can have them more times a week, but you're required to meet once a week for at least an hour. And you're supposed to discuss things, maybe things you weren't able to get to last week, or maybe you gave your apprentice homework and you can discuss that. A lot of things, but it's kind of a teaching session, especially for the first semester when you're trying to learn all this biology or all this physics or all this electricity stuff. But that's number one. Number two is hands-on training. This is the fun part. This is where whatever your mentor does, you get to go to their office or to their lab or to their workshop, to their area of work, and you get to do stuff that you've talked about on paper. So I, with Mr. Garen Foster present, we went to the crime laboratory and we tested out a bunch of things such as identifying saliva, making sure things were blood, a ton of things. We got very high powered UV lights, so high powered that they had huge batteries on them. And if they ran for more than 3 minutes, they start getting very hot. That's how powerful they were. And we were told not to shine in each other's eyes and stuff like that. So we went around the entire lab and looked at where there was invisible material that is not clear to the naked eye, and trash cans, chairs, drawers. I mean, there were tons of genetic material all over that. And that just means uh, things from your skin. Perhaps it's from sweat, so maybe a chair you sit on for a long time. But there was a lot of it, and it's interesting to see that. Lastly, what your mentor has to do, and this kind of goes with the teaching and the mentor meetings and stuff like that, is provide research and direction. And my mentor was fantastic in that I am technically enrolled online for forensics classes. I did that at the beginning of the year, and I did some work on it just to get an idea of actual crime analysis on the crime scene, because where my mentor works is not on the crime scene. That's CSI stuff. My mentor works in a lab, so he said if you want to figure out stuff that happens on the scene, maybe take these courses. You could see how they arrange bones and identify things and stuff like that. And direction, if we were ever going on a path that he didn't feel was right, he would steer us back. And I'm so happy about that, because there could have been many times this year where our meetings could have just gone off the rails. But he made sure that even though we talked about stuff, again, I've known him for 4 years, so we talked about stuff, but he made sure that when we left the meetings that we each gained something from that. So I was very happy with that. And I'm saying a lot of things, and it seems like, oh, meeting once a week and going to labs, that's a lot of work. It's really not, especially in the scope of high school. it's really not that much time commitment. It's 1 hour a week, and usually my mentor and I would meet at like McAllister's or Starbucks or a local coffee, and we would get a drink or maybe some food and then talk, and I would write notes. And that's just for our meetings once a week. And if you ever go to the lab like I did, since it was a government facility, I couldn't go there as often as I would like to. I wish every meeting was in the lab, but of course, it's a government facility. And so we only did really experiments, they're not meetings. And we did that around, if I would say about once every 3 months. There were times where he brought things to me, but there were only a few times where I went to the lab. So it was fun. It's very fun to go to the lab, but it's not that much time commitment. It really isn't. But now, the, the reason you're all here, the tagline in this entire thing, how do you solve a murder? And there's so many answers to this. There seriously is ballistics. You can look at blood splatters. You can look at so many different things. And that's something my mentor always talked about, was that any crime, no matter how small, there it's a giant puzzle, and you're just one piece of the puzzle, and you have to do your job right in order for the puzzle to make sense. Because if everyone just slightly didn't do their job right, the entire image would be shifted and twirled, and just so it wouldn't look good. So you're just one little cog in the machine, but it's so fulfilling to have a crime be solved and know that you were a part of it. So I will actually be discussing the biology portions rather than the many, 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 many other branches there are in forensics. And so what we deal with, or what my mentor and I would deal with, would be blood samples, genetic studies, chromosome analysis, statistics, and we didn't really talk about this, but we're going to need to for this little experiment I have for you. Criminology and victimology, which is studying how the criminal thinks and how they choose their victims, basically. And you see, that's the main portion of like media, like Criminal Minds. That's usually what they're focusing on. They're putting themselves in the mind of the murderer and thinking, where would they go next? So, as you can probably tell, almost all of these, excluding the criminology and victimology, have to do with some sort of genetics or material or something to do with who you are, your DNA. And so that's what we use in crime analysis. We actually use DNA to narrow down the options. I'll explain in further detail. But as you can see here in a very simplified graph, you have a lot of data and you put it together so it becomes very, very, very clear who this person is. And we do that through a thing called STRs. STRs are short tandem repeats, another acronym, another 3-letter acronym. And this diagram that I have up really helps understand that. And you probably remember a little thing from biology in high school, GTAC, the building blocks of DNA. That's what forensic biologists use to identify criminals. And what I mean by that is, in certain places in your chromosomes, of which you get one from your father and one from your mother, in certain locations, there are repeating frequencies, as I'll show here. So in this diagram, there is blue, red, blue, red, blue, yellow. And it repeats through the entire strand until it doesn't, which isn't shown here. But for instance, if the blue, red, blue, yellow, if that is repeated, let's say 13 times, that is 13 repeats. That's 13 STRs. And so when we get a blood sample or another sample of genetic material, it goes into a machine and it is brought up in this diagram. So the top portion right above where the graph is, you can see D3S1 358. That is the address. That's the best way to put it. It's going from general to extremely specific. So kind of the opposite of your home address. Your home address, you start with your street, then your city, then your state, and then your nation. Here, it's nation, state, city, street. So D means DNA. Thr- uh, 3S, it's singular, and that's at locus 1358. So think of that as the address. It's a small portion on your chromosome, which is usually very different for a range of people. So that's why forensic biologists use it. So here we see 15, 16, 14, 16, 24, 26, bunch of numbers. And you can probably assume those are the STRs, and that is exactly true. It is graphically shown in these spikes as these STRs are run through the machine. And so what does that mean? It's just a bunch of numbers. Well, we can say if someone has a 15, 16, as in the first example, at that locus, which I said previously, then maybe they have blonde hair. If so, I've just excluded, I think, 70% of the population, because I believe 70% of the population has brown or red or black hair. So we're down to 30% of the population, which is very, very good. And like I said before, with statistics, you get closer and closer and closer to the person who committed the crime. So blonde hair, 14, 16, they have blue eyes, okay? 24, 26, their pinky smaller. A bunch of things. And not only does it describe what someone may look like or their genetic profile, but this is entered into a machine called CODIS. Not a machine, but an actual program. So this profile is entered in, and if this person ever commits a crime again and their genetic material is found, CODIS will say, hey, these two match, meaning these two crimes were committed by the same person. So if we ever find someone and arrest them, or they're brought into the precinct and they're forced to give a sample, and CODIS says, hey, what you just gave me matches something 4 years ago, then you can charge them for everything that they did. And the machine, which I spoke about earlier, looks like this, presented by the lovely Riley Foster, who is the friend I spoke about in in the beginning that I met in world geography. That is Mr. Foster's son. Uh, and so, as you can see, it's a little difficult to see, but near his face there are sort of needle-like protrusions, and it runs through a wire which has a current of, I believe, 50,000 volts. And on his left hand, you see a black portion. That's where the laser goes, which actually not only color codes, but it breaks up STRs and stuff like that. So I've given you all the information. In the link below, there should say something that says get your genetic profile. Click on that, and you'll notice it's not a real genetic profile. It's actually a card. But remember your card. This isn't a magic trick. I'm not trying to take your money. Just click the link below, click on it, and then get your card. I'll give you a few seconds to do that. All right, you're back. Fantastic. Because there's been a murder. Sorry, I know it's a little depressing, but now we all have to figure out who did it. And every single one of you is a suspect. That's just a fact, because if someone died in this room, then one of you had to do it. And we can't use CODIS. We don't have CODIS. It's very expensive to get CODIS. So we're going to be using something that I made, the computerized official frequency filing exporting engine, or as many people like to call it, coffee. This is our murder weapon. Very deadly stuff. But we have found a blood sample on the weapon, and we put it into coffee, and we have simplified it to make it visually appealing. here it is. So, the 4, 7, 15, 6, 8, 10, 3, 4. Bunch of random numbers. So what does this mean? Like I said previously, these numbers stand for things that you may physically possess. So blonde hair, blue eyes, shorter pinky, disfigurements, stuff like that, skin color. So we are going to be doing the same thing. There are, I believe, 54 or 56 cards in one pack. So we're going to be using those numbers. So 4, 7 could mean blonde hair, blue eyes, whatever. For us, that means the card is red. So we just excluded half of the population, or half of this room, which we're considering our population. Because now, if you have a black card, you didn't commit the murder. It is proven because the murderer has a red card. And this is the best example of the easiest way to exclude 50%, because the easiest way to exclude about 50% of the population is by looking at the chromosomes which determine gender. So if you were to go back to the diagram I showed earlier, you would notice that the chromosomes that are shown on that diagram, bottom, it's the middle left, they have XY chromosomes, which means that it was not a woman who committed the crime, it was a man. So 50% have been excluded. Now we have 15-6, again, could mean a variety of things. For us, it means it's diamonds. So now 75% of the population has been excluded, 50 from it being a red card, and another 25 because it's diamonds. So we can exclude the heart cards. So we're at 25%. 8, 10, again, a variety of things. It's not a face card, so queen, king, jack, none of that. 3, 4, it's odd, and this includes the ace. I know it's not a number, but it does include the ace. So we have ace, 3, 5, 7, 9 of diamonds. Already, after just 4 attempts, we're down to 5 cards out of an entire pack, which is pretty good. But let's move on. And if you're moving along with me, you'll notice this one has a 1, a 7, and a 2. And that doesn't make sense, because I said earlier that you get 1 chromosome from your mom and 1 from your dad. So why do you have 3 if you're only supposed to have 2? And that's because along the way, somehow this got mixed up with some dirt or maybe someone else's blood or genetic material. But in other words, it's contaminated and it can't be really used. So we're not going to even bother with it. And we're going to move on to the 5-2 at the bottom left. It means it has a sharp edge. So this would be ace 3, no, ace 5, 7. Ace 5, 7. Because everyone else has a smooth edge. So again, we're at 3 cards. And lastly, it has a letter. So if we review our findings, we have found that it's red, it is diamonds, it is an odd number, it's not a face card, it has a sharp edge, and it has a letter in it. And for those of you who have already caught on, you already know what card it is. But if we look at this, everything matches up. There's not anything that says it's odd and even. That would make sense. Everything lines up for the murderer to be possessing the ace of diamonds. So if you have the ace of diamonds, you're the murderer. I can't get you in quarantine, but you're the murderer. In ISM, when we learn all this and when we're able to convey all of it, we're supposed to make a little product. And so my first idea for a product was going to be a crash course style video, which would be teaching people real forensic biology, because my mentor had informed me that I wasn't going to be able to do experiments. It costs thousands of dollars just to get materials. It wouldn't come in time. It needs to be signed by so many people. We weren't going to be able to do experiments. So he said, in all honesty, the main issue is that people get the media confused with real life. And I asked him what he meant. And he said that Criminal Minds, NCIS, all these forensic TV shows are making out to be something that it isn't. The forensic biologists don't go out and in the police car and hunt down the bad guy. They stay in the lab and they are just doing their work. They don't try to infer things. A large thing that my mentor taught me was that forensic biologists work with facts. They don't infer anything. When they're in front of a jury in court testifying about their findings, they cannot, even if they feel in their heart that, this guy murdered this person, they cannot say anything that isn't factually correct. So a lot of the times people in sexual assault cases will say, did you find genetic material on this woman? And the forensic biologist will say yes, and then they'll ask, did it match the genetic profile of this man? Yes, it did. Well, the defense attorney comes up and asks, well, is there any scientific proof that it was not consensual or stuff like that? And there's no proof of that. There's no proof whether it was consensual or if it was rape or anything like that. So the scientist, the forensic biologist, has to say, there is no scientific proof that it was not or was consensual. So you just have to deal with the facts. And so he wanted me to convey that to the public. First, it was going to be through a crash course video. Then we moved to the idea of an actual film through a first person point of view, which got delayed and then eventually canceled due to quarantine and stuff like that. Eventually, we ended up here at the final product, which is a little difficult to explain. You'll have to experience it for yourself, but it's a choose your own adventure through the forensic world. And the best way I can explain it is if you've ever been in VR or a simulation or anything like that, it's kind of like that. That's how it was supposed to be for the first person point of view, but we just moved the script into a text format, which looks like this. This is an actual screenshot from my product, which if you're interested in trying, there is a link in the description below. You can begin the experiment and you can run through it. And there are options where you make choices and your choices affect what outcome you get. That's the entire purpose of it. So if you choose to, I don't know, pick up a glass or to have a bite of cereal or something like that, it takes you down a different timeline. So your result will be different than your friends or something like that. So this is the beginning. This is the actual text and the preview on the right. So you can actually read a few pieces of the dialogue. And this is actually how it looks mapped out. This is exactly what you just saw, but in a logic map. And so, like I said, it's a choose your own adventure. So you can see where the pink box that says 1, it breaks off. And you can see one timeline. The other actually goes down, and I wasn't able to get it on screen, but it takes you down to a different timeline, and you get different events. And so there's a lot in there. There's so much that on the right-hand side of the screen, you can actually barely see a screenshot of the entire map. You may need to pause the video and get your glasses, but that is the entire logic map with all the timelines and all the different variations. It's so large that even when I took the screenshot, it's so small that you can't read anything and you can barely make it out. It's a lot of work. I'm very happy with it. I do think it helps my mentor in a great way. I think it shows how real forensic biology works. It runs you through multiple stages of the process, not just the biology, but the actual CSI. And you're actually the criminal at one point, and then you're on the jury. There's a bunch of different timelines that you can go down. Please click the link below if you're interested. Worked a lot on it. I'm very proud of it. But I do appreciate you all taking some time during your quarantine to experience this with me, to listen to me talk for a little bit. I hope you learned a few things, especially the biology portions. That's my job as an apprentice, to spread the word of forensics. So thank you all.